with all of you. So again, this is the November Energy Cohort session, and I'm Emily Jones with LISC. And the Energy Cohort, as many of you know, is co-led by MACDC, New Ecology, and LISC. And we're so excited today to have James Petersen join us from Petersen Engineering. And James has over 30 years of engineering experience that ranges from multifamily housing to municipal infrastructure. So we're so pleased to have him speak to all electric building technical specs today. And I think what we'll do is we'll try to have a pretty interactive facilitated presentation, and then we'll reserve about 15 minutes for discussion, Q&A with you all. So please, as we go along, if there are questions, please put them in the chat, and then we'll hold those till the end unless there's a burning question that we'll jump in and share the answer to. So thank you again. And I think without further ado, I will pass it over to Lauren Bauman from New Ecology, who will facilitate the discussion with James Petersen, and we'll go from there. So Lauren, to you.
Great, thanks, Emily. Well, again, thanks so much, James, for being with us here today. So this session is really by popular demand. We had surveyed the Energy Cohort, and folks expressed a lot of interest in not only talking about sort of the big picture ideas around building electrification and how that fits into, carbon neutrality goals at the municipal and the state level, and how that relates to the projects that they either have in their portfolios and are rehabbing or building new at this point, but really an opportunity to dig into the details a little bit and really talk about what are the different types of all electric HVAC and domestic hot water systems that you're typically seeing deployed on affordable housing projects of different sizes and scales, and really just an opportunity to talk through those and talk about where you see sort of the best application of each of the technologies, whether it be retrofit, new construction, both of those things. And what are some things that owners and developers should have in mind as they consider these different types of systems for their projects. So that's our goal for today. We're really looking forward to hearing your feedback. It's a great opportunity to really step outside of a particular project and just generally talk about these systems in a way that hopefully people can use moving forward as they're making decisions about their projects. So Emily, I think if you can go to the next slide. So we threw a couple of background information slides in just for folks to really kind of understand some of the context of the conversations we're going to have about each type of systems. And metering is one of those sort of background pieces of information. Metering is an important factor as you think about who's paying for what in your buildings and how utility allowances factor into that. So there's a lot of thought that goes into how you figure out how you're going to meter your systems in the building. So I just wanted to talk about, three of the most common types of metering schemes that we see in affordable housing. So, the first bullet here, all systems. So there we're talking about sort of major mechanical systems. So HVAC type systems, domestic hot water type systems, on a central electric meter. So when we say central electric meter, we're talking about the house meter or the meter that the owner pays for. And so fundamentally that type of metering is when the owner is taking responsibility for the utility costs associated with the mechanical systems in the building, heating, domestic hot water, potentially ventilation too. The second bullet here is where you may make some decisions to actually put the HVAC systems or domestic hot water systems on each tenant's utility meter. And so in that situation, that utility account is owned by the tenant and would specifically be paid for by that tenant. So any systems on that meter paid for by the tenant, and obviously your utility allowances would need to accommodate for that in the way you think about the sort of operating pro forma for the building. And then fully master metered, maybe we see that one a little bit less, but more typical on supportive or elderly housing, where each tenant doesn't have an electric meter on their own that covers plug load or anything else. Really everything in the building is covered by a central meter. So a little bit of background information on metering. When we talk about all electric systems, refrigerant is a really important thing to understand, because most of these all electric systems, at least the high performance ones, are deploying refrigerant to do the work of producing heat or domestic hot water. And so refrigerant, I've heard refrigerant described as the sort of global warming or greenhouse gas emissions you've never heard of, impacts you've never heard of, right? So people think of carbon dioxide and carbon as the primary source of global warming and climate change. But refrigerant gases are actually pretty impactful from that perspective as well. And you'll see in this chart, different types of refrigerants have different types of global warming potential. And so all of these numbers are as they compare to carbon dioxide. So if you look at this, carbon dioxide is given a ranking of 1. And this relates, the numbers that you see here relate to how many times more potent refrigerant is than carbon dioxide. So technically, when you have a refrigerant-based system, if it's installed well and it's performing well, you don't have leaks. And so this refrigerant would stay in the system. But I think what we've learned through the use of these refrigerants across the country in different ways is that many times these systems are not totally sealed, and you do end up having refrigerant leaks, which can have pretty significant global warming implications. And then you also have to think about disposal of refrigerant at the end of the day. So I think refrigerant is a topic we're starting to see more and more people pay a lot more attention to, and it is really closely tied to all electric type systems. James, is there anything else on that slide you want to mention about refrigerant?
I would just say that the trend is looking good, and we're starting to see these very low global warming potential refrigerants coming to the marketplace, and that's very, very encouraging.
All right, and then this slide, we've talked about this a little in other energy cohort meetings, but just again, a little bit of a refresher around the way that these high performance electric systems or heat pump type systems are working. So I like to sort of compare this, to something that people are very familiar with, which is your refrigerator, right? So your refrigerator is essentially using refrigerant to pull heat out of the inside of that box, right? And transfer it to the exterior, thereby cooling that space and keeping your refrigerator cold. And so if you take a look at the icon down at the bottom, it's the same way that many of these heat pump type all electric systems are working. They're using electricity and refrigerant to produce a cycle where they are absorbing heat from a particular location and rejecting it to another. And in the winter, you're actually absorbing heat from the outside air and rejecting it into your building in order to heat it. In the summertime, that cycle is reversed. And so you're absorbing heat from your interior space and rejecting it outside. So you're cooling that system. And typically these heat pumps have what we consider greater than 1-to-1 performance. So for each unit of energy that you put in, you get more than 1 unit of energy, heating energy out of the system. And that's what we typically refer to as coefficient or performance, or the efficiency of the system. And so, we've talked a lot in the past about how you do need to be very careful when you think about all electric systems as it relates to the cost to operate those systems. And that's because, the spark rate that's sort of reflected in this slide, right? Where the amount of energy, heating energy that you get for a certain dollar value from therms is just more expensive when it comes from electricity. Here, if you look at this equation, it's essentially 5.4 times more expensive to produce 1 BTU of heat with electricity than it is with gas. And so that means that it's really, really important to try and get as high efficiency mechanical system as possible. So you really want your all electric system to have a high coefficient of performance, even at low temperatures, as much as possible, to try and mitigate that cost increase related to electrification. And then in the next slide here, it's why it's also really important that we address heating energy load in these buildings and try and really reduce the amount of heating energy you need. So this way you're spending less to heat your building. And, with new construction buildings, that's really high performance envelopes. In retrofits, it's really thinking critically about your building envelope and making sure you're doing as much as possible to reduce the thermal transfer as well as the air infiltration into the building.
Hey, Emily and Lauren, can we go back to the previous slide briefly? Great. So I just wanted to, Lauren, you did a great job there, but I just want to emphasize a few things. One thing about heat pumps and air source heat pumps is it's very difficult to get your head around the notion that there's heat when it's 0 degrees outside. And that is the beauty of the heat pump. There is heat in the air when it's 0, and the heat pump is extracting heat. It's not easy. So you can see on the graph on the right, in January and December, that's representing that the efficiency of the air source heat pump is at its lowest when the outdoor temperature. So a difference between gas